Okay, so this is the waterproof boot problem, and it's based on a 2002 question. It is not exactly that because I expanded it to cover all three types of design. So a manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. So they're telling me that when I put the boots on, I have no way of knowing which treatment I have. The company recruits 100 volunteers in Seattle, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of 6 months, the boots will be returned to the company to be evaluated for water damage. The design diagram will describe a completely randomized design. By the way, we're not going to demand that you use a diagram, but thinking about a diagram and making a little sketch to yourself tends to improve scores, not because we're giving you extra credit, but you tend not to forget things. So first thing, I need to always, since this is just a completely randomized design, which means I'm putting everybody's name in a hat, I need to randomly assign to the volunteers. And what am I assigning? I'm assigning 2 treatments. So my 2 treatments are the new waterproofing method and the current waterproofing method. And at the end of time, I'm going to compare the water damage. So my response variable is the water damage, and my explanatory variable is the waterproofing method. And I have 2 levels of that. I have a new method and a current method. Okay? So how do I explain it? Place the names of the volunteers in a bin and mix thoroughly, or a hat, draw 50 names. The first 50 name drawn will receive the new waterproofing method, and the remaining will receive the current. After 6 months, the boots from both groups will be evaluated for water damage to see which is most effective. Okay. Design a diagram and describe a randomized block design that is blocked on outside and inside jobs. Well, that makes sense. If you work inside, your boots probably are not going to have as much water damage as if you work outside. In general, we would think that to be true. So we're going to block first, and we always block before we do the random assignment. So I'll block. So I have those who have inside jobs and those who have outside jobs. Then I'm going to randomly assign to the treatment. So please note, I randomly assigned after the block. I always randomly assign. Random assignment always occurs after the block, or we can say within the block, but always afterwards. And so I'm assigning to the 2 treatments, which are new waterproofing and current waterproofing. And over here, so basically I have an inside job with new, inside job with current, outside job with new, outside job with current. And at the end of time, I'm going to compare the water damage. Again, my response variable is still water damage. But here I have 2 explanatory variables. One is type of job, and the other is the waterproofing method. Type of job had 2 levels, inside and outside. Waterproofing method had 2 levels, new and current. 2 times 2 is 4. So in this case, I have 4 treatments, which is 1, 2, 3, 4 treatments. So how am I going to explain how to do this? This is the part you have to show. You didn't have to show the diagram, which would have saved me because I can't draw fast enough on a test. So separate volunteers into groups based on whether or not they have an outside job or an inside job. So in other words, I'm blocking them based on that. Place the names of those with inside jobs in the hat and mix thoroughly. Draw half the names. The name draw will receive the new waterproofing, and the other will receive the current method. Notice I had both treatments going to inside jobs. Then on the outside jobs, place them in a hat and mix thoroughly. Draw half the names. The names drawn will receive the new method, and the remaining will receive the current. Once again, both groups in the outside job receive both treatments. After 6 months, evaluate the boots for water damage to determine which method is more appropriate or more effective. A manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed. Design and diagram a matched pair that has 100 volunteers. Okay, so I'm going to randomly assign to groups, but my treatments have to be swapped. So in this case, this one's group's going to wear new waterproofing on the right foot and the current on the left, and this one is going to be switched. And you're like, and then at the end of the time, you're going to compare damage of boots. And the answer is, does that really matter, Mr. Spencer? And it's questionable whether it does or not, but I'm going to give you an example where it might. If you're walking and you see a big puddle, I'm right-footed, so I try to step over the puddle with my right foot, which means my left foot rarely ends up in the puddle, but my right foot might not make it, so it might. So by swapping the boots around from person to person, we control for those types of differences. So always, 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 you need to have one group with the reversed order. One group that's one time it's tested first with one group and tested first with the other group. So how do I run this? Place the names of the 100 volunteers in a bin and mix. The first 50 names drawn will receive the new treatment on the left foot and the old on the right foot, not food. The last 50 names will receive the new treatment on the right foot and the old on the left. At the end of time, compare the differences in damage. Could this match pair be done double blind? So the question is, does either the evaluator or the subject have to know? And the answer is no. Neither one of them needs to know what it is. And because it didn't change the appearance, then this could be done in a double blind manner. All right? The person wearing the boots is unable to tell the difference in the boots and needs not be told which boot has which treatment. The evaluator of the boots is unable to distinguish and doesn't need to know either. All the evaluator is going to do is go, yep, the right foot shows more wear, or the left foot shows more wear, whichever the case may be, but he doesn't know which one the person has. So which design, the completely randomized, the randomized block, or the match pair is best? And because every individual is different, the best method is the match pair design because it controls differences from individual to individual. For instance, it controls for things like weight, areas of town, how much time is spent in what areas, etc. And I know growing up, I remember seeing in elementary school, people, well, specifically, some girls would go to school and it'd be raining and they'd be wearing a nice frilly dress. And I don't know how in the world, but it never got a drop of rain on it or any mud. If I was 3 blocks away from a mud puddle, it was on me somehow. Okay? So basically, there are differences in the way individual. Okay? All right.
So I have a question on that.